Hi, welcome to ClickMyProject.com. This video will lead us to the demo of high performance and high scalable packet classification algorithm for network security systems. Packet classification is a core function in network and security systems. Hence, hardware-based solutions such as packet classification accelerator chips or TCAM have been widely adopted for high performance systems. With the rapid improvement of general hardware architectures and growing popularity of multi-core, multi-threaded processors, software-based packet classification algorithms are attracting considerable attention, owing to their high flexibility in satisfying various industrial requirements for security and network systems. For high classification speed, these algorithms internally use large tables. Those size increases exponentially with the rule set size. Consequently, they cannot be used with a large rule sets. To overcome this problem, we propose a new software-based packet classification algorithm that simultaneously supports high scalability and fast classification performance by merging partitioning decision trees in a search table. While most partitioning-based packet classification algorithms show good scalability at the cost of low classification speed, our algorithm shows very high classification speed irrespective of the number of rules with small tables and short table building time. Our test result confirmed that the proposed algorithm enables network and security systems to support heavy traffic in the most effective manner. First of all, we have to create ring 1 and then we have to create ring 2. Using these rings, we can select the source and then select the destination. After selecting the source and destinations, the data must be selected by the source. This data is transferred to the destination. Before that, the data is to be embedded with packet informations. This packet information contains the source IP, destination IP, source port and then the destination port. These data are embedded into the selected data and then the data is transferred to intermediates. Before that, we have to select intermediates. There are two intermediates are present. They are intermediate 1 and intermediate 2. First of all, the data is transferred to intermediate 1. In intermediate 1, the classification is done. In that classification, it will check the IP address of the source and then destination and then the port numbers. If all are correct means then it is successfully classified and then it is transferred to the intermediate 2. The intermediate 2 do the classification process. It checks the source IP, destination IP and then the port numbers of the information present in the data, and then the data is transferred to the destination when the classification is done successfully. The destination checks the packet information that is embedded in the data, that is source IP, destination IP, source port and then the destination port. If it is correct means then the result is the classification is done successfully. Otherwise, it will show the result that it is not done successfully, that is the classification is not successfully done. Let us see the demo of high performance and high scalable packet classification algorithm for network security systems. First of all, we have to run the project. For that, we need to select homepage.java, right click the file and then select the run file option. Now click this image. And then here we have to enter the number of nodes in first ring, that is the first cluster, and then we have to enter the number of nodes in second, then press create ring 1, then press create ring 2. Now the rings are created. It contains 10 nodes. First of all, we have to select the source node and then we have to select the destination node, then click next. Now press the select button. Now we have to select the data that is to be transferred. Press any data and then click open. Here we can get the details like file name, location, format, and then the size of the data. Then press view. Now it displays the information that present in the data and then click next. Now press packet information. It displays the source IP, destination IP, source port, and then the destination port. Now we have to embed this packet information to the data. It is automatically embedded when we press the combine to data button. Then click next. Here we have to select the intermediate nodes. For that we have to select intermediate 1 and then the intermediate 2. Then click next. Now the data is transferred to the intermediate 1. It is node 5. Now press view data. The intermediate 1 receives the data and intermediate 1 do the classification. It is the classified data. Now the packets are successfully classified. Then press next. Now the data is transferred to the second intermediate, that is node 6. Now press view data and then press the classification button. Here also the packets are successfully classified. If it is not successfully classified means it will show the message. Then click next. And then the node 3. Node 3 is the destination that we selected already. So the data now transferred to the destination. For that we have to press click view data. Now the data is viewed to the destination and then press the classification. Here also the classification is done successfully. If the classification is wrong means then it will show that the packet not successfully classified.